I'll hit record here.
Recording in progress.
Hey everybody, it's March 28th, 2022. This is C++, or Introduction to it, at College of the Sequoias, CSCI 1. Today we're looking at what is in our section as Module 9, and it's going to be constructors and vectors. So what I've done is I have pulled in our point structure from the triangle project we did last week, along with the method that went with it. And don't forget, when we have methods, we have to scope them by doing the name of the structure followed by the scope resolution operator. Double colons. Okay, so let's just go into the main and let's set up a point. Why is it? What's going on here? There we go. I'm going to create a point. Let's call it my point, my PT. And we can pre-populate or populate it if we use curly braces and put in our values. We have an X and a Y. These are our variables. Another word for them is properties. Since they're inside the point, they're the properties of the structure. And we'll come down here and we can pre-populate them. That we do them in the order the variables come in. So they come X, Y. So I can put like maybe 3, 4 for the point 3, 4. There we go. That's had an extra sign in there. We don't have to do that. We could always have just left the point, my point blank, and then done my PT dot, dot, and it brings up a list of the parameters, or the properties are in blue and the methods are in purple. And just assign them by using the dot operator. I can change this to 4. All right, let's make it 6. And I can change the Y value by doing dot Y. And we can see if we do the print operation, my PT, and use the display point method, it had no input, so we just leave it empty. And we'll do it before and we'll do it after that we change the values. So it said 3, 4, then it went to 6, 8, and then it has that CR right here that we don't need right now. So this thing has always got, we always want something in it. Like, I don't want to just have my point like that and then do a display point. What happens when I do that? Here I haven't actually populated it yet. So what happens? I get garbage. I got nothing good to come out of it. So we want to create something that pre-populates. We want to pre-populate points when they are fabricated. They are made. Or when they are constructed. Hence, we do something called the constructor. So within the methods, we have the constructor method. And the constructor method is always, always, always the same name as the structure or class. So in this case, it'll be called point. And And since I already have access to the variables x and y, I don't have to take anything in. But I did set it up here, so I should set it up down below. And I'll come down here and make I gotta put it in. And again, I need to scope it. I always got to scope the methods, even if they're the constructors. And we'll just make it a constructor. So here, this is the constructor. So we can give it some default values here. So there's always something. It's not just garbage. For a point, a good one's the origin. So I could say x equals 0 and y equals 0. And let's just run it and see what happens. Now notice I still haven't populated it here. And last time we did this, we had that garbage. So I'm going to run it. And now I get it pre-populated to 0, 0. And then I reassign values 6 and 8 to it, and I don't want to run again. So we made this constructor method and have its implementation down below, okay? Something to note about constructor methods, never, ever, ever put a cout or anything like that in the constructor. It's not good business. You can always do the display point or display option later. We just want to pre-populate values or the properties. So we can give it some default values for the properties, I should say. Here. So this is one way of doing it. It's worth noting every object has a constructor and a destructor. And you'll learn about destructors when you do memory management in CSCI 2. That's where you look at destructors. Constructors are here. If every object has to have a constructor, you might ask, well, how the hell have we been making the point before this? Before I put this constructor in, point void, I was still making points. Well, the computer, the IDE, our integrated development something environment, integrated developer environment. It's pre-populating it for us. It's creating the constructor for us. But we can create our own. And there's another way of doing this same one. I can also tell it, I can actually tell it to take in things. So let me turn off the other one. And I can tell it I want to take in a double that will be argx. And I want to take in a double that will be argy. And if I have the other one turned off, oops, I can actually set these equal to 0, 0 as a constructor or default setting. Again, I have to put this down below. I'm going to say x equals argx in this case, and y equals argy. Let me comment this one out real quick. It doesn't like it because I made one and I didn't use it. And it doesn't know what point is because I haven't scoped it yet. So now let's see what happens. I have build errors. What are they? Where's the red? Oh, you're not supposed to have the equal 0 in the implementation. Just don't put the equal 0 in the implementation, just the prototype. Okay, that should do it. There we go. That's what it didn't like. And so now it's taking that 0, 0. When we first created it, when I first created the point, I didn't put anything in it. So it used the default settings that I made up here. Okay, and I can change those. I don't have to use 0, 0. I could have chose 1, 1 or 1, 2 even. If I do that, it's going to pre-populate them to 1, 2. So that's what we mean by constructor. It sets up a default setting. I think for points, the origin is the best option. So I'm going to go back to that. This constructor is good for something else, though. Check this out. I can make another point. New point. Oh, wait, I don't use new. Some point. And I have this constructor set up, and it's done. Notice it's got parentheses here. I can do parentheses here. I can say 3, 4. And that's kind of just like doing this part right here. That's like doing point, some point equals bracket 3, 4. And I can show you that by doing a C out of that. We will do some point and display point. So that's really cool. That's another easy way to set up stuff, especially when you know everything that's going to go in it, but you have to create this constructor. You can have more than one constructor. Okay? It's kind of advanced, but you can have more than one. I'll turn that back on. I will uncomment out this one. And now I want to point out it's got a problem. This, I don't have any values, but here I've got, this one is set up as not taking anything in. And this one has values for when nothing's taken in. So it's got two scenarios. So I'm going to copy this line. And comment that one out. When you've got more than one constructor, you do not want to put defaults like that. Okay? Take out the defaults for more than one constructor. So the defaults kind of go in the void one. And that's what I've got. If I look down below, I've got x equals 0, y equals 0 in the voided one. And then for the other one that's got both, it just whatever value's there is that. So I can actually do that there. I can get that 0, 0 just by doing this right here. Same thing. This one was the sum 0.1. Believe it or not, all the objects have been like this. This ability to do this constructor, all the objects are like that. Guess what? Int x equals 10. X is an object here. So I could see out x here. Maybe I should do another space. We know, well, shit, we already know what that equals. That's just going to show x equals 10. Instead of putting that one, I can do int x bracket 10. And it's going to get the same thing. The chair's kind of, I'm sliding out of it. I twisted my knee this weekend. Sucks. All right. So these are some constructor things. It's kind of cool that we have these options. We could set one up where there is a constructor if they just give the x variable. I could do one that says point double arg x. Or I could do double arg y, but I can only do one. The constructors, if I do them like this, you can, where it only takes in one argument, I can't do it for two different ones because the compiler doesn't know the difference between argY and argx. So I could set it up where we take in just one. And I gotta scope this. And we'll say x equals argx. And we could default y to 0 since we didn't get anything for that one. So we can make a constructor with that, and when we implement that, let's just say my point is, we'll put in 5. You know what, I'm going to move this down below where I use some point later on. There we go. Now we're keeping our stuff together a little bit better. So if I do this one, it's going to look for the constructor that takes in only one argument. And that is this one right here. And goes, okay, it's going to be argument x. What do you want me to do with argument x? And we come down and look at the implementation. And it says, well, take argument x and set that equal to our x property. And just fill in y with 0. And we can see that happen up here when we run. Okay, it started off as 50. It's kind of neat. So we can do that where we can take in one property. How often would you do that? I don't know. It doesn't seem like this is something I would do with points. So I'm just going to go back to having like the regular point, my point. For an example, and I'm only going to do this to illustrate what's happening, I want to show you that this is getting called when we don't do anything like that. I'm going to put a C out here. I'm going to say constructor called. And I'll get rid of it as soon as I run it once. I want to show you what happens when we do it. I want to show you that it is doing this in fact. Because we did these point things just fine before and nothing ever happened. So that should trigger right here. I have my point, and there's nothing that's being taken in. So it should say the constructor was called. There we go. Constructor was called just for that first point. So I'm going to take that back. I'll leave that in for a second because I want to let's look at another one. What about an array of points? Ooh. I will comment those out. A point, my array, and we'll go with size. I'll give it a size. Let's go constant. Oh, I'll just finish it right there. And I gotta say constant size equals, yeah, 5. Sounds good. And let me make a function that prints out a point real quick. So let's make a void print array, and it will take in a point argument and a size. I gotta say int size, don't I? And I'll come down here and make that bad boy up. It's in our functions. And for int I need that in brackets. Int I equals 0, I less than size, I plus plus. I could just tell it to print out arg bracket, and then I need to put in I. And each one of those is just the cell, and each one of those cells or elements is a point. So the dot operator gives me access to the points in that array. So this is an array of points. So we'll display it out. Welcome, David.
Thanks.
And I'll call it up here. Let's go up here and print it out right after we made the array. Print array. We'll pass it my array, and we'll pass it size. And so what's happening here? So I made an array of points. So I have an array of points. There's going to be 5 points in my array. And I did not pre-describe what they are. So each point, it's going to come up here and go, what's the constructor method that we formed? I formed the constructor method that takes in nothing, so it's going to access this one. And so it's going to come down here and go, what should I do with each one? The one that says avoid is going to have this one in it. It's going to set each one to x is 0, y is 0. And it should do it every time for every element of the array. I'm going to take this out after I do this, because you shouldn't have couts in the constructors. But I kind of wanted to show you what happens, that it calls this thing every time. So if I run the program, we've created an array of 5 points, and they should have all been pre-populated using that constructor to 0, 0. And notice it's telling me that the constructor was called 5 times for that. So I'm going to say no. I'm going to take this out.
So are you passing the entire structure in that function?
I was passing the entire object that I created in that one, yeah. That's probably not the best way to do it. I should probably pass the address. But I was trying to go for simplicity here. So since Dave just got here, I'm going to give him a quick summary of what he missed. We can pre-populate things. We can make a default setting using something called constructors. And when we do them in the programs, they're methods. and they're called constructor methods. They have the exact same name as the structure itself or the class itself. They don't have any return. It doesn't say void or double or anything in front. It says the same thing. And you can actually make a constructor for one level for each argument you want to take in. So this one is zero arguments, a void. This is a single argument where it takes in the x. Alternatively, I could have chosen y, but I did x. And this one does both. And when you're doing it, that's the prototype up there. You come down here, you implement them. The one that took in nothing, I set the default to the origin. X equals 0 and y equals 0. The one that took in the x, I said, well, okay, well, x equals what the input was, argx, and we'll set y equal to 0. And the final option was it's passed me both, and you can set each one equal to it. To illustrate something that you had missed, I'll comment these out real quick. And comment these out up here real quick. And uncomment this one. If you just make one that has all the arguments that you're going to have in it for the prototypes, you can put defaults here. I can say equals 0 here, and then when I run it, it's going to grab that one. So if I run it, let's see, I wonder why that one's red. Let's see. Should still run. So here, that's my only prototype, my setup, argx equals 0. I'm telling it these are my inputs, and I set them equal to 0. And that's called right here. Let me, oops, where is this? Oh, there we go. I need to close that one. There we go. Let me change it and show what happens. I have 0, 0 here too. That's not really helpful. And I will run it again. So here I didn't put anything in. Here I put 2, 4. And we'll comment out that for a second. So for the my point, it automatically did the 0, 0 from the default setting up here. Then we reassigned the values to 6 and 8 right there. Printed them out again. That's where we got this line. And then I did some point, and instead of making it blank, I put in 2, 4. And I immediately printed out, and it gave me the 2, 4. So this type of constructor it's kind of like an all-in-one package when you set the defaults right there. If you do use that one, and I like that one myself, if you use that one, the equals 0 does not come down into the prototype. I don't put equals 0 here. I don't do that. So these are just basically setting up default situations. What do we want for a default situation?
So you can set a default up top in your prototype, basically.
Right.
And then still run it down below as a method.
Right. So if it
take
doesn't,
in other arguments, okay.
If it doesn't take anything in, it will go with my defaults that are listed in the prototype. But if they do pass in an argument, it will use the arguments they pass in. And it is I had done, let me change that to 3, 4 here. That way it matches this syntax here. We did this before by saying curly braces. I think you and I talked about this just the other day.
Yep.
With the constructor setup, we can do the parentheses thing and not have that equal sign. And it's the same thing. Integers are the same setup. you could, instead of doing x equals 10, you could do x parentheses 10. It's just not as common with the standard objects like integers and doubles and stuff.
Makes
I'm
sense.
going to leave those other ones turned off since this is the one I like the most. I'll leave the other ones turned off, but they are there. Then we looked at doing in the point array. That's right when you would pop it in. Oh, let's see how that one. So I set up an array of points of size 5. And since I didn't use any constructor call, it's going to use the default settings in the constructor up here for each point. So if I comment out all those,
So when you're passing an object into a function like that, does it look at it like an array?
since I set up the array, the print option as an array.
Okay.
Print array was set up to take in an array of points. I specifically set it up like that.
Okay.
Of course, we don't need to keep those. Like once I've got the array set up, I could go in and change some of these. I could say my array bracket 0.x equals 1. And I could do this for each of them. Actually, I will. Let's do this. For int I equals 0, I less than size, I plus plus. Let's set it equal to a random element. My array bracket I equals 1 plus rand 100. Rand mod 100. And I gotta say, when I do it, I gotta say dot x or dot y.
That's what I was about to ask.
Yeah, I think you were about to say that, weren't you? Let's do that for the y one also. Let's do y also. And since I'm using rand, did I include rand or seed time up top? I did. I should seed it though. So let's seed the rand. srand time 0. And now we can take a look at it. What kind of points do we get now? What we expected, some random points. All right, so if I want to add to this array, if I want to make this array bigger, this kind of sucks. Like if I wanted to make an array of size 6, I really need to declare a new array of size 6, add the old points over to it one at a time, and then fill in the final one. So arrays are very limited. So let's go with our other topic for today, which is the vector. The vector is in the standard template library, STL, which means we can include it. Include vector. Okay. So this is in the STL or the standard template library.
Real quick, and what is, never mind, I think I got it.
Okay. Oh, shit, undo. So let's go down and take a look at all that. I will turn off the arrays, because the arrays are useful or can be, but like they can't grow. So let's just look at making a vector. The way we set up a vector is we say vector and we put brackets, the arrow brackets. And the data type we want the vector to be is what we put inside. So I'm going to make an integer vector. And I'll just call it my ints. Okay. So this sets up or instantiates a vector of ints or integers called my ints. And conveniently, it will print out the same way. I can do a for. I'm going to grab the print loop from down here because I don't want to retype it. And instead of writing arg I display points, we'll change that size in a second. I can just say my ints bracket I. It's got the same setup. I guess I need to see it out. See out element I of the vector contains my ints bracket I. And when we want the size, we do not need a predefined size. We can call on my ints and use the dot operator, and size is one of the options. We're going to say my ints dot size. You got to have an empty parentheses because it's a void argument. And this will do the same thing here. Actually, we haven't populated it yet, so let's see what happens when we do. Nothing shows up. How do we populate an integer vector? So let's take a look at what happens when I do the dot operator here. And we get a bunch of things, but the star ones are the ones that are the most common at this point. Pushback is what we're looking for. I'm going to use pushback, and I'm going to use parentheses to fill in what I want to use. So I'm going to use an integer value. Let's go with 13. I like 13. And I can do some more. Why is it not populating? Oh, I used a capital M. That's why. Do a few. And now when I run it, it's going to show us the 13, 15, and 17. Element I is a terrible way to say that. Maybe I should have said there we go. Okay, so what's going on here? Like a vector is like making like a stack. Or maybe like a tube. Think of it maybe like a tube. And pushback, we're shoving shit in. So like let's say I shoved A in. A comes into the tube, it's over here. Or in terms of the stack, A is right here. And then I push in B. B gets shoved in. It's the next element there. In terms of the stack, we're putting it on top. And I could put in C and D. And all of these are done via pushback. So pushback adds to the stack. I don't really care for the name, so I'm trying to give you pictures that work, that at least give it reasons. The way we take away from the stack, we can delete the last entry with Pushback. For me, the easiest way I can describe why it's pop, picture this as a stack of bottle caps, and we're just flicking off or popping off the top item. So that would go away. If I pop back is a void entry, so I don't need to tell it what I'm putting in. And I'll show you it right now. So that's kind of like what we're doing with these vectors. After I do those, I can do a pop back. And we won't tell it what. And then we'll, you know what, maybe I should make a print vector. And all I gotta do is tell it what I'm taking in. Here it's an integer vector. And I will just come copy and paste my code. And I got to change this to say arg. And that needs to say arg. And now I can just use printback. I'll come up here and I'll replace this with printback. And I'm just passing in my ints. I don't need to pass it a size because it can figure out the size all on its own. And then after I have done the pop back, we'll do it again to show the difference. Maybe I'll put out a C out, you know, a new line, put some. So I had 13, 15, 17. I did the pop back. It took off the last element. Okay. Let's go take a look at the C++ library on for vectors. C++ vector. We'll go to our trusty C++.com and we'll look at all the stuff we have to choose from. We have constructors and destructors I was telling you about. We haven't done the constructor for the vector yet, but we will. Well, no. Vector already has its own constructor. Iterators you're going to learn in CSCI 2. And a lot of the vector stuff requires iterators, so we're not going to touch on it yet. Just know that it's coming in CSCI 2. Size is something we were able to reference right here. There's some other ones, resize. I don't know that it's all that helpful. You can look at them as you see fit. Empty's not bad. Empty's a pretty good one. It tests whether the vector is empty or not. So it's a Boolean. So we could actually use this to, in fact, they do it right here. While my vector, if it's empty, it'll return true. So the exclamation point is while it's not true. While it's not true, go through and add stuff up, this one does, and then pop it off. So we could do something similar like that. Let's come in here and I will, why is that flickering? Let's comment that out. Let's set up something similar. While exclamation point myints dot empty bracket. So this is saying while it's not empty, I can, why don't we print out the list? And then we can do a pop. And then I'll enter in a space. Oh, I need parentheses. So if I do that, I think I need another space in there. It's just going to look like a wall of text. Yeah, it does. Let me add another end line. Oh, I know why there's two in a row, because I got it printing right here, and then it immediately prints again right here. But I think we can see that it's reducing. Let me comment that one out. We'll see it a little bit better. So it has them all. It keeps popping them off. And when it's done, it's done. I was doing this with double or integers. We can do this with doubles. I could make a vector double. Let's call it my double, my dubs. Like that. Let's, oh, where's that random thing? I'm being lazy. I can do, let's not use size. Let's say 5. 7. Let's have fun with it. And we will go with my dubs. Oops. Line your fingers up on it. Dot pushback. We'll push back 1 plus rand mod 100. So here I declared my dubs to be a vector, a double vector, or a vector of doubles. We're going to populate it with 7 random numbers. And why don't we come down here and make this my dubs.
So is this more sort of like a variable size array?
Yeah.
Interesting.
Well, no. This is what's being entered.
No, I understand that. What I'm saying is, like, you're not specifying the size of your vector.
Right. That's the beauty of the vector.
The vector is like a variable size array.
Right. It's okay. Exactly what it is. It's a variable size array. It can grow. It can shrink. It can do all sorts of fun stuff. It's good stuff like that. Let's come down here and do these.
Can it be multidimensional?
In its own way, yeah. Like we're gonna do points. We'll make a point vector in a second, which is kind of like multidimensional. You could do a hexagon vector. You got different stuff in there. You could pass in an array, make an array, a vector of arrays, which is kind of crazy in the head. My print vector is set up to be integers though, so I need to change this to double. I guess I could have made a new one. Print back my dubs. Or if Oh, that's what I want to do. This will hit enter first. Hit enter there. If my dubs empty, if that's true, print out vector empty. You know what? I could actually do that right up in here. And then do an else. Else, we will print back my dubs. That's where we'll do it, the print back. And those shouldn't be curly braces. Or those should be curly braces. Let's see. What are you mad about now?
You don't have a close parentheses on your if statement.
You're right.
So your while my dubs is not empty. Oh, now you're changing stuff. Never mind.
That'll put 2 spaces between it. We'll do that on right here too. Okay. So while my dubs is not empty, we're going to pop one off the top or delete the latest entry. I don't need that there. We're doing that at the end. Then we're going to go, is this empty? If it is empty, we'll say the vector's empty. Otherwise, we'll print what's currently remaining in the vector and we'll start the cycle again. So let's see how that goes. So our full vector was 83, 62, 46, 41. You can see that, and each time it's popping off the last one. The 42's gone. Now the 84's gone. And we get down to the bottom and it goes with vector empty. And just to show that it grows, it shrinks and grows, the pop back kind of shows that it shrinks. I populated that one automatically, but let me go with like my dubs. And then I'm going to push back. Let's add one more after my random numbers. And we'll just push back 101 because we know that's not in the random 100.
I got to bounce.
Okay. So this shows it growing. We got the 101. I grew the array. Even though it started off as 7, I added another one to it. We can grow and shrink the vectors, which is what makes it way cooler than the arrays. Okay. I can do the same thing. Check this out. I can choose to say a size. I could say const size. I don't want to say const. Size equals 7. Or let's go with something shorter. 5, 4. And I can tell my dubs, I want you to start off of size 4. And I can do a quick loop here. I can say I equals 0, I less than my dubs dot size. And we'll just tell it to push back I. Let's push back I+1. . Let's lower this down to 3. So I'm going to do a my dubs print real quick. Oh, print back my dubs. And then we'll have some end lines in there to show that it's actually growing and to show what's happening here. Ooh, WTF. Are you not liking that I said int size? What do that? Oh, I'm not putting anything in the initial ones. Let me not do my dubs dot pushback. Let me do my dubs bracket I equals I plus 1. There we go. Let's try that. Because I want to push back. I wanted it to actually change the current values. There we go. So what's going on here is I can treat it just like an array, but rather than using a bracket, I use parentheses. And I can tell it how big I want the vector to start. So I tell it to start with a vector of size 4. Then I went through, and since I knew they existed, I was able to access them with my dubs and use array notation. Since they were made already, I can use array notation to populate them. Even though they're vectors, I can still do that indexing with the bracket thing. Okay. And that was here. Then what did we do? We went 0, 1, 2. We did 3 more things. We pushed back random numbers, 45, 25, 96. And then finally, we also pushed back one right there, 101. And then we started popping them off. So that's kind of a cool thing to do. I'm going to copy this part right here. I'm going to comment it out. I'll comment this part out. Show you all something else that's cool. Oh, let's come up here and do const double pi equals a cosine negative 1.0. And that means I need to include CMath. That was just to generate pi real quick. I can come down here and do the same thing, but I can tell it 4, comma, and pre-populate it with pi. I could have chosen any number, but I have pi listed above. I'm going to do that. And so this should pre-populate, starts the vector at size 4 with pi set to each of the values. Then we'll print that out. Oh, that's where I want it, right there. Then we'll do the pushback thing and stuff like that. Let's see that work. So I was able to pre-populate it with the values I wanted. This is the constructor syntax for some of the constructor syntax for vectors. This says how many vector elements to put in the vector, what value to put. This one up here was constructor syntax. This is called constructor initializer syntax. And so the constructor part here was give the vector 4 elements. And down here, the constructor starts the vector at size 4 with pi in each one. That's kind of cool. So we showed the pushback adds 2, pop back takes away, and it's always from the last element. If we come over and look at the other things in C++, notice we have things like insert elements and erase elements, so you can put stuff in the middle of the vector or take stuff from the middle of the vector. Those require, unfortunately, iterators, and you're going to learn iterators later on in CSCI 2. But know that there's more tools here available. Back to my setup. What else did I want to show you about vectors? Here I just showed it each. Here I showed out each value. But maybe I want to tell it what I'm popping off. So let's put that in here. See out. We gotta tell it what value was popped off. And so what can I put in here? How can I access the last element? Well, I could use mydubs.size. But like if it's size 3, the elements only go 0, 1, 2. So I could do size minus 1.
Except it doesn't pop off, take that last element off.
Oh, you're right. I should do this before it. So we're telling it what elements popped off. We'll pop it off. We'll print the new vector. This should work. So like, let's say if its size was 3, it'd be 0, 1, 2 are the elements. We wanted to show number 2. 3 minus 1 is 2. I think that's going to show it to us. All right, so we set up the array. We pre-populated it with pi's. We added 3 random numbers. We got our 101. It's telling us what was popped off. And it keeps going through. That's kind of cool, isn't it? So this is how you can access the last element rather quickly. When you did the size is changing each time, and I don't need to know what the size is. I just tell it to do size minus 1. We could play a guessing game. Let me turn off that my dubs. And let me bring my other my dubs. Did I ever use ints in this anymore? Let's create it. redo it. Vector double. No, let's go with, yeah. I'm going to go back with ints. I'm going to do all that. We'll leave that in there. No. I am going to do this. Decisions. We're going to make my dubs again. We're not going to predefine it. We're just going to tell it to do, let's go with like 10 numbers. So I'll comment that out, and I'm going to comment out the deleter thing. So that's all we've got there right now. So we've populated the vector. Let me make sure it's working the way I intended it to work. Surely it's not. Expected an expression line 69. All right, it's got random elements. Okay, so we could make like a search the vector. So we'll do like a search the vector project here real quick. So I'm going to make a Boolean, and I'm going to say, I'm going to call it did find. No, I like better. Found it. That's going to be our Boolean. And we'll set that to start off as false. And then, oh, maybe I need a value. So let me make a double user input. And we'll do a cout. What value would you like to search for? Cin user input. And we'll do the good old cin ignore just in case. And now what we can do, so we've got this mydub vector. Let me make sure it's working as I wanted it to work. All I've done is added the cout real quick and the option to input. So I can tell it to look for like 96. Okay, so that's working. So now let's do like a search thing. Let's go for int I equals 0, I less than mydubs dot size, I plus plus. We'll do an if mydubs equals the user input. We'll say where we found it. Not mydubs, if mydubs bracket I. Found at element I. And we'll also tell it, if it does find it, we'll tell it to change the found it to true. And that way it'll go through the whole loop, it'll look for it, and then we can do an if down here. If found it equals false, then it didn't find it. We can cout not found in the vector. I hope that worked. I did a lot right there without testing it. Let's see. Let's give it a try. So where's 95? Oh shit, it was in there twice. Look at that. Found it element 3. Found it element 8. That's kind of cool. Showed both. So this is a good like little search project we could do there. It's probably better with like a integer rather than doing a double. But I did basically populate it with the rand ends up being an integer, so it didn't have any problems with it. So let's kick it up a notch. We were using our standard ones here. This seems like something that should be done in the play again thing. So we have that in the play again thing. Okay, so well, we learned we started using the structures. So why don't we do one with the structure? So I will comment out all that good stuff right there. We'll comment out this, even though I put it there just now. I'm going to comment it out because we don't want to look at it right now. We're just going to look at using stuff that we already did. We made the structure point. Let's make a vector of points. Maybe we'll call it my points. Now, let's pre-populate it with. Let's just say we want size 5. Okay, let's make since we've got a vector thing with points, maybe we could do a display vector here. A method for it. Can we do that? So void display vector. Now, the vector isn't inside. Nah, that's not going to work. But we can do it down here. Display point vector. And we will pass in a vector of points. And we'll come down here and we'll declare that bad boy. And since it's taking the point, how are we printing out the vectors here? I can just basically copy this. Speed it up a little bit. In fact, it's even got arg. Is there anything that doesn't work there? Oh, it's not arg.I. It's actually arg.I, since they're points now. Arg.I display point. And then we'll add in another end line. That should work. So we pass in a vector argument. It goes through the vector one element at a time. It says I'm going to print out the ith element, and then it uses the point display method since it's got points in it. It uses the point display method we've already created, and then adds a line, and then it goes to the next element. That should work. So this is display point vec. I'm going to use that up top. And we're going to pass it my points. Now, what we're doing is we're making a vector that's got 5 elements, and each element is a point. The point has a constructor setup. Since I haven't told it what the values are, this should pre-populate all of the elements, or all the points in the vector to zeros. Does it do that? Look at that. Bam. Now, we could have a different vector, but also point. Let's not pre-populate it. Let's call this other points. And we can go through and do a loop in I equals 0, I less than, I don't know, 8, I plus plus. And I can, maybe I'll create a couple doubles here. Double temp X and temp Y. And we'll say temp X equals 1 plus rand mod 25. And we'll do the same thing with temp Y. And then we can push back we need to pass it a point. So I can pass it temp X, temp Y. Is that going to work? I've got that set up in the middle like that. That's what I'm pushing back. So I'm not really using the constructor call here, but I am pushing back those values. That should work. And then we could do the display points there as well. But this is called other points. Oh, I still had the other one running. So we got, let's put some space in there. That looks bad. There we go. So we got a vector that's got 8 points in it. There's 2 of them that have an x value of 1. So we could do that whole search engine thing here as well if we wanted to. We could do that search for x values if we wanted to. That's kind of like what vectors are all about, though. So vectors are arrays that grow and shrink. When we have iterators, which is in CSCI 2, we start going over it. We can take from the middle and take and add to the middle. Anywhere inside the vector. As it is now, we can only do it at the end. Could we design something where we could do the search in the middle and then remove the element? What could we do about that? Where's my search program? Let me come find it. Let me just uncomment that. There we go. And we're not using my dubs now. What am I calling this vector up here? Other points. Nope, let's go with let's use my dubs. Let me turn on all the stuff with my dubs. Oops, keep clicking the wrong damn button like a scrub. Guess I needed a little bit more. Don't need that one. Let's comment out the point one. I think that was a good show of how points works. It's just the same thing as doing it in the others when we put it in. So let me make sure I've got this set up where it's still doing the double and we can look for a value. Okay, so how could I get it to remove, like, let's say we find element, let's say it's got 10, 20, 30, 40, 50, 60. And I want to find and eliminate 40. So we want that one to, oh, I don't have my camera up. There we go. So this is our vector as it is. We want to eliminate the 40. We just did the find thing. We were able to find the element. So we know how to find the element it's at. Now we can't do delete from the middle using the pre-programmed stuff, the iterators. But there is something we could do. We could take each value after that and reassign it to it and then chop off the last one. Right? So how would that work? Like this is the ith element. So I could do within there, I could do a 4 int, let's go with j. It starts at I and it goes to the vector size. And we'll increment. And what do I kind of want it to do? I want vector bracket j. I want to put in it what is in vector bracket j plus 1. Which means I probably can't go all the way up. Maybe I need to go up to -1 here. Vector size -1. Now, what this is doing is
then you're not going to get your last value.
What?
You go to vector size -1, aren't you going to miss your last value?
Well, no. When it gets to here, that'll be j step. It'll grab the last value there.
Oh, yeah, I see what you're saying. Okay.
So we do the -1, and then we could do the pop back, right? And it doesn't matter if this was the 60 or the 40. We've moved all these up. So we would have 50, 60, 60. And then we're popping that last 60. So it should say 10, 20, 30, 50, 60. I think that'll work. Let's take a look at that, doing that in here. Let's slide down my damn chair again. Okay, so we have it shown what the vector is. I don't need this found it business. Actually, let's do that in there. Let's leave that in there. We'll say not found in the vector, nothing deleted. So here, what we're going to do is in here, that's where we're going to put our little function. Where is it? Why is that not moving? Okay, it's stuck there. Rude. Oh well, I'll make that bigger again. I do have it written down. We had for int j equals I, j less than my dubs dot size minus 1, j plus plus. And oh shit, that looks bad. There we go. So what I had said is we're going to make my dubs j equal my dubs j plus 1. And we got to let it go through the whole for loop, move them all up. Then we pop back. And then we'll ask them if they want to delete another. Let's throw in another end line in here. Let's see if that works. I think that'll work. So let's say, let's get rid of the 91. Oh, wait. I don't know if it reprints it out. Yeah, it doesn't print it out. And we need to print out the new element. Or new vector. So then we'll print. What was it called? Print vec. My dubs. All right, now let's do that. Let's see what we get. Couldn't see if it deleted it or not. Ooh, I see 250s. Let's see if we can get rid of both. So it's got 89, 65, 46, 92, 13, 7, 11, 30. Look at that. We popped them both off. We waxed them both. Let's get rid of that 92. And so now the 92's out. That's kind of cool. Let's tell it to do a value we don't have in there. Let's make sure that works. Not found in the vector, nothing deleted, so it restores the vector. Could we make a sort vector with this? I know you guys will do this later on in another class, but could we sort this? Let's try to edit this where it actually sorts it. Let's think about this. So if we want to sort it, maybe we want to sort from the lowest to the highest. Oh, that might be it. Well, it's already 5:45. Maybe we'll do this on Wednesday. Maybe we'll make a project on sorting it on Wednesday. Any questions? All right. Well, I think we could call it a wrap for now then. I will stop sharing. If no one's got any questions, I'll hit stop record. Where is it? Stop recording and...
Recording stop.